Good morning, everybody. Today we're going to go over the double angle and half angle formulas for sine and cosine. Another just kind of gross formula that is useful for finding exact values without a calculator on some of the non-standard angles that we've been working with, but still using those to our advantage. So here they are. The sine one is the easiest of them. It looks pretty much like a double angle, but the important thing to hear is that just because you multiply the angle by 2 doesn't mean you're going to be working with twice that size. So it's not as easy just as multiplying sine by 2 if you're multiplying the angle by 2. And if you ever get stuck on these, you could always revert back to the sum of two angles, right? If I did sine of theta plus theta, that's the same thing as sine of 2 theta. Cosine of theta plus theta is going to be cosine of 2 theta. Same thing with tangent. We aren't going to practice tangent, but this is it. Cosine has a ton of them. It just has to do with establishing identities. Those come out as you see. So you get to pick one. Sometimes it's easier to use one over the other. Most of the time you're going to need to know sine and cosine anyways. I generally stick with the top one, but you can do either one, or any of the three. Doesn't matter. It should get you the same answer. They might look different just because of how things are simplified, but the decimal should be identical. So that's the nice part with these. Pick which one you like. With sine and tangent, you're stuck with the 1. So get used to it. All right, so this is a similar situation to what the problems that we've had in the past, where we need to find sine of 2 theta, cosine of 2 theta, given one identity and also the quadrant that the angle exists. So the quadrant we're working with is between pi over 2 and pi, which just means that cosine is going to be negative. So we have our triangle that we're working with, our angle, 3, 5, and then if you use Pythagorean theorem, you get this is negative 4. Again, cosine's negative, so that's where the negative 4 comes from. So from this, we get that cosine of theta equals negative 4 over 5. And we're going to use that information to come up with sine of 2 theta. So sine of 2 theta is 2 times sine of theta cosine theta. Sine of theta is 3/5. Cosine is negative 4/5. And the hard part's done. We just need to multiply it out. So our denominator is 5 times 5, or 25. 2 times 3 times 4 is 24. So we're dealing with negative 24. So sine of 2 theta is equal to negative 24/25. Easy peasy. Another thing you could think about, you could always revert back to, well, if I know what sine of an angle is, I can figure out what cosine of that angle is. So you could piece this together and come up with cosine of 2 theta if you wanted to. But I'm just going to practice. I'm going to just practice this skill of plugging it into the formula. Pick one, doesn't matter. Because we have sine and cosine, you can use cosine squared, cosine theta squared minus sine theta squared minus. We have all the information we need. It's not that bad, so let's go with that. Cosine theta is negative 4/5. We're going to square that. Woof. Negative 4/5 squared minus sine squared is 3/5 squared. 4/5 squared is 16/25. It's negative being squared, that's positive. 3/5 squared is 9/5. 9/25. 16 minus 9 is 7 over 25, and we are done. The nice part about this is you don't have to figure out if it's positive or negative. The formula will do it for you. Where half angle formulas, you don't get that luxury. So I do want to point out all of these say plus or minus. You are not going to write plus or minus. You have to figure out if it's positive or negative. And it's all dependent on where that angle should be showing up. I'll show you what I mean in a second, but you have to figure out if sine is going to be positive or if it's going to be negative. Based off of that, pick positive or negative. Everything else is the same though. So there is a little extra step to these, not just plug it into the formula and you're done. It's also more complicated. You got a square root of a fraction, which is never fun, but we've been practicing that, so should be manageable. All right, cosecant of theta is negative root 5. That means that sine of theta is negative 1 over root 5. You can rationalize that if you want. It would be negative root 5 over 5. Doesn't matter which one you use. I'm going to choose this one just so I don't have to deal with bigger numbers and still a square root, but it shouldn't matter. Let's go for fun. Let's do this one. It says cosine is negative. So that means that we're dealing with quadrant 3. Both cosecant or sine is negative. Sine's negative, cosine's negative. The only place that exists is in quadrant 3. So we're working with this angle of theta. Cosine is going to, let's figure out sine first. So negative root 5, 5. 5 squared is 25, minus root 5 squared is 5. So 25 minus 5, this is negative root 20, which is negative 2 root 5 as well. So pick one. Cosine of theta, which is the more important one for both of our formulas. If you notice, all of our half-angle formulas just depend on cosine, which is interesting, I think. But cosine of theta, the one we care about, is negative 2 root 5 over 5. I would deal with the rationalized version of this just because we're going to have to do a lot of operations with it, and I'd rather just use this information. To save space, I'm going to erase how I got that, so if you want it, you're going to want to pause it for a second and get it down. All right, so the one other thing, if we're working, so what we do know is that this was in quadrant 3. Half of quadrant 3, so from pi to 3 pi over 2, let's pretend that it is pi. If I divide pi by 2, it's pi over 2 over here. If I divide 3 pi over 2 by 2, it's 3 pi over 4. So theta divided by 2 should be somewhere in between pi over 2 and 3 pi over 4. Okay? Just by dividing this by 2, we get that information. This tells us that sine of theta over 2 is positive, and cosine of theta over 2 is still negative. Okay? So when we go to our formulas, we are picking the positive version for sine of theta over 2. We're picking the negative version for cosine of theta over 2. And you have to do this calculation or this mental exercise each time. But it's as simple as that. It's going to be in quadrant 3, and we know that sine is positive there. We know cosine is negative there. Sorry, quadrant 2. All right, so sine of theta over 2. Sine theta over 2, we said is positive square root of 1 minus cosine of theta is negative 2 root 5 over 5, all over 2. That's technically your answer. It's not simplified at all, so we need to get through that. And to do that, I'm going to kind of zoom in first on our numerator. We're subtracting a negative, And if I add those together, this is 5/5, so 5 plus 2 root 5 all over 5. Now I'm multiplying that by 1/2, so I'm going to do that here, and I'm going to add the square root in. Divided by 2, multiplying by 1/2, they mean the same thing. So here we have the square root of 5 plus 2 root 5 over 10. And from here, even though there's no adjacent square root or close square root, that 10 is still being square rooted. So our denominator is not rationalized, which is bad news for us because we have to do some extra work here. To do this, you might think about rewriting it like so. Now we can multiply top and bottom by root 10, and we get we're going to multiply inside by root 10, or we're going to multiply the numerator by root 10, which we're bringing into a square root, so it's going to be just multiplying by 10. All over 10. Okay. And you're done there. So again, you're just plugging it into a formula, but it does just take more work. Again, we've done the hard work, figuring out what cosine of theta is, also figuring out that cosine is negative, so cosine of theta over 2 is negative. Ugh, gross. 1 plus negative root 2 root 5 over 5 all over 2. And same kind of story that we're going to have here. It's 1 minus 2 root 5 over 5. I'm zooming in on the numerator. This is 5/5, so 5 minus 2 root 5 all over 5. Now I'm going to bring in the rest of it times 1/2. And we have 5 minus 2 root 5 over 10. Square root of that. You can't. Scratch that thought. All right, same deal. We're going to multiply by 10 and 10. So we have 50 minus 20 root 5 over 10. The only thing being square rooted is going to be the numerator now. So this is cosine of theta over 2. This is sine of theta over 2. Pretty gross, but we have the luxury now of having exact answers, which is such a dignified answer compared to a decimal. All right, I'm only going to do 3a for this part because it is the portion that is dealing with the half angle formula, which is the hard part of the formula. 3b and 3c are confirming that you got the right answer. 3b wants you to work through finding sine of 195 using the sum formula. So figure out what of 45 plus 150, basically. So you can do sine of 45 plus 150 and see if it's the same answer. It might look different because you're using a different formula, but if you check on your calculator, they should be the same value as the decimal. So that is my little quick walkthrough for 3b and 3c. But using the half angle formula, finding sine of 195, you're going to do a little trick here. 195 is half of a number, and that half of a number, we're just going to double to figure out what it is. If we double this, we get 195 times 2 is going to be 390. And we know what this is. That doesn't feel like a number that we know, but if we take away 360 or a full revolution, this is 30. Right? So we know cosine of 30, so we can figure out what sine of 390 over 2 is. Both of these mean exactly the same thing, but this is phrased in a way that we can use our half-angle theorem or half-angle formula. All right, so to do this, sine of 195, this is where it kind of gets weird. Sine of 195, 195 is down here, so we know that sine of 195 should be negative. Okay? Even though cosine of 30 is positive, sine of 195 is negative, so we know that this should be a negative value. That is probably the hardest part of this thing, is just figuring out if it should be positive or negative. But once you have that decision made, it's plug it in. So 1 minus cosine of 390, right? Alpha, we're saying, is 390. Alpha over 2 is 195, and all of that's over 2. Negative. Now, cosine of 390 is the same thing as cosine of 30. Cosine of 30 is equal to root 3 over 2. So, plug it in. Don't worry, this one's a little bit easier. This is negative 2 over 2 minus root 3, so 2 minus root 3 over 2 over 2. This is the same thing as multiplying by a half, so you get negative 2 minus root 3 over 4, which is a perfect square. Ooh, nice. The little things in life. So I'm going to rewrite this like so. And we know the square root of 4. Yay. Over 2. And if you check using the sum of two angles formula, sine of alpha plus beta, I would recommend using 45 and 150. You know both of those. Or you could use a different combination if you wanted to. You could use the subtraction, or you can use the difference formula, whatever you want. And then you could also check with using your calculator, see if they're coming out the same decimal. But that is it for this one, and it should be it for the week. So hope you have a nice weekend, and I'll see you next time.